Okay, so what we're going to do is we're going to look at domain and range. Domain and range. And these are two really important concepts in math. They're really important in higher levels of math. So we've got to understand what they do and why they do it at this level so that we can understand what it means at higher levels. Okay? So we're going to talk about it in two separate pieces. We're going to talk about the domain first. The domain. And the domain is all possible values of x. All possible values of x. If you're looking at a function, we want to know what values of x work. Now, the domain is equal to all real numbers, and the other thing that we're going to look at is what's called interval notation. So interval notation for all real numbers looks like this. All the possible numbers starting at negative infinity and stopping at positive infinity. Okay? The domain is all real numbers except for two cases. Number one, if you have a fraction. If you have a fraction, you are not allowed to have 0 in the denominator. So if you have a fraction, set the denominator equal to 0. Set the denominator equal to 0. Whatever value you get for x is not in your domain. Okay? So if you have a fraction, set the denominator equal to 0. This value, the resulting value, is not in the domain. Okay? Alright, the second instance where you could have a domain issue, you're going to be a domain of all real numbers unless you have a fraction or an even root. Okay? An even root, like a square root or a fourth root. Okay? You cannot have what kind of number in a square root or an even root. Okay? No negative numbers. Okay, so what does this mean? That what you'll do is you'll set the number under the radical, or set the expression under the radical to be greater than or equal to 0. Greater than or equal to 0. Okay? So these are the only two instances where the domain will not be all real numbers. Okay? So let's look at the domain then of a problem. Let's say f of x, or a function of x, or y equals something x. So let's look at the domain of a number of something like 3x to the 4th plus 1. Okay? And I ask you for the domain. The first thing you look for is a fraction or a radical. Look for a fraction or a radical. Since there is no fraction or radical on this problem, we say that the domain in interval notation goes from negative infinity to positive infinity. This is like saying that the all real number values of x will be true. Okay? If I have a function like f of x is equal to 3x squared minus 2 over x minus 4, and I ask you to tell me if there's a domain restriction or what numbers we can use. If I ask you what the domain is, the first thing that you do is check for a fraction or a radical. And what do we have? We've got a fraction. Okay? So what we do, the rule is to set the denominator equal to 0 and solve it. And in this case, we get 4. Okay? 4 will not work for this problem. It's not in the domain for this problem. So in interval notation, the domain for this problem is going to go from negative infinity to 4, and from 4 to infinity. And with interval notation, a couple of things. Number one, when you're using interval notation, then you're going to have a starting number or a smallest number and a largest number. So your interval notation will be in numerical order, just like a number line. Okay? And you use parentheses if you're not included. So all your friends get to play and you don't, you're not included. You use parentheses. You use brackets if you are included. So if this is a number that works, we use brackets. If it's a number that doesn't work, we use parentheses. So go back to 3x squared over x minus 4. On this problem, the number 4 doesn't work in the denominator. Okay? So I can't include it in my domain. And if it's not included with interval notation, I use parentheses. So that's kind of how those guys work. Now, the other thing that is a very, very, very common mistake, very common, is to look at the top and set the top equal to 0 too. The problem with that is you can divide any number into 0. So I could say 0 divided by 7. That is 0. We can do that. It's totally a legal move. But I cannot divide a number by 0. It's undefined. This is not a legal move. So 0 in the top, no problem. 0 in the bottom, big deal. Okay? And then let's look at one more problem that we might have. Let's say something like f of x equals the square root of 2x plus 4. Okay? And I ask you to tell me what the domain is for this problem. And when you look for domain, you automatically assume all real numbers unless you have a fraction or an even radical. And in this case, we have a square root. It's an even radical. And so what we're going to do is follow our rule. If we have an even radical, we're going to take what's under the radical and make it be larger or equal to 0. So we want 2x plus 4 to be greater than or equal to 0. And then solve this and pay attention to what you're doing so you don't make a mistake. So I'm going to move this 4 over by subtracting 4. And that gives me 2x is greater than or equal to negative 4. Don't make a mistake here. This is a negative 4. And then divide everything by 2. So I have x is greater than or equal to negative 2. This is my domain. This is my domain. So how do I write that in interval notation? Well, the smallest number that I can use, is negative 2. And I can take the square root of 0. So I can include the negative 2. And then I go all the way out to infinity. Now, infinity has parentheses because whatever number you think of that's the largest number you can think of, just add 1 to it, and now you've got a whole new number. So there's no way to specifically pick the number infinity. And since you can't specifically pick the number infinity, we can't include it as a specific number like we can -2. So the domain on this guy then is going to go from -2 to infinity. Okay, so range. The range of a number. The range of a number are all possible. Whoa, that's terrible spelling. All possible or used values of y. All the y values that are being used or are possible. Because if you look at a graph, you only look at a very small portion of the graph. And so we infer from looking what y values are going to be used. Okay, so the range is all possible used values of y. Okay, so just a real quick example of this guy. Whoa, that's not a very straight line. Let's get a straight line here. So here's an x-axis, here's a y-axis, and let's mark this off, x and y. And we've got some line that does this. Okay? And the arrows mean that the line goes on forever and ever and ever and ever. So we want to look at the y values that are being used. So we look for a minimum y value. We'll look right here. See that line right there? That's a minimum y value. Okay? And let's say that that minimum y value is on the y-axis is -3. Okay? So I have a minimum y value of -3. Now, when I look at my domain and range and I use my interval notation, just like with domain, I need to know the minimum value of y that's included. In this case, it would be -3. So for my range, I start at -3. That's my smallest value. And then I look for my largest value. Well, you may be looking and you might go, hey, that's my largest value right there, where that maximum is right there in the middle. But that's not true. That's part of your graph, yes. But what do we know about your graph? It continues to grow on both edges. That's what those arrows mean. So this graph continues to go up, 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 up. And since it goes up and up and we can't see it, we infer that it's going to be infinity. So we would just come over here and say that, hey, our maximum y value is infinity. And again, we can include the point -3. It gets a bracket. We can't include the point infinity, so it gets a parenthesis. And that's the range on this particular function. Okay? All right. So let's look at some other ones. Let's look at some other functions. Let's say we've got something that looks like, let's see here. Let me lock these guys down. So let's say we've got a function, we'll put this one in blue, that does this. Okay, what's the range of this guy? So look for your most minimal value of y that is either used or possibly going to be used, again inferring what happens where we don't see. And it would be -infinity because the arrows point down, 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 down. Okay? And then going up on the upper half of y, what y value would be our maximum? Again, it would be infinity because the arrows symbolize, the arrows on the tips symbolize that our graph is continuing to grow or fall. So even though we don't see the graph going through 100 million, jillion, trillion, billion, we assume that it does because the arrow indicates that the graph continues to grow where we do not see it. Okay? Let's look at one more. Let's look at one more. So what about if I have something like this? Let's say something like and this is all I gave you. Now, let's talk about this guy. What's the domain and range of this guy? Okay, what's the well, let's talk about range. So, we want to know the smallest value of y that's being used. And where does that occur? Well, here's one value of y. Here's a value of y. Here's a value of y. Here's a value of y, and there's a value of y. So I've got 5 things to look at, right? So I want to know which one is smallest. Wouldn't it be this guy right here? He has the lowest y value. So let's say that his y value here is -6. And so let's call this point right here the point -6, 4. And let's call this point right, whoa, that's backwards, isn't it? Let's go 4, -6. And let's call this point right here 5, -1. And let's call this point right here 2, 1. And this one right here, -2, -2. And this one right here, -3, 3. Let's go -3, 2, actually. Okay, so here's all the points for my graph. Okay, so we've decided that -6 is definitely smaller than -2, -1, +1, and +2. So my range then starts at -6, and we include the point -6 because it is being used. And then we go all the way up to what point? We go all the way up to the highest value, which in this case then is 2, and that is my range. Okay? Then what we want to do is we want to look at x values. So I want to know the domain from my smallest x value, which is what? From -3, and again, -3 is included, to my largest x value. Largest x value, largest, I go all the way till I get to the largest x value, which is 5. And once I get there, that's the end. And so this then becomes the domain and the range for this particular problem. Okay? All right. So interval notation, you will use a lot in higher math. Okay? A lot in higher math. There will be very few inequality signs in the higher math. It's a lot of interval notation will tell you where to look for things. So here's your Cliff Notes version of interval notation. If you have a bracket, you're talking about a number that can be included in the conversation, in the problem, on whatever it is you're working on. Okay? The parentheses would indicate that you're talking about a point that isn't included, but you can get really, really, really close to, but not all the way to, so that you're including it. Okay? So that's the difference. One is included, one isn't. The range is going to be your smallest y value all the way to the largest y value in interval notation. And the domain is going to be the smallest x value to the largest x value in the interval notation. So this is how you'll use interval notation, and it'll be used a lot in your future mathematically. Okay?